Okay, we're recording now. If you're just watching this, what you missed is on a Mac, Command dot does the same thing as Command C. Okay. So I briefly showed you a few things. We looked at pipes and redirection. There's some good resources here on what goes on in the command line. These are kind of focused on um, getting you the big picture of why we use the command line in bioinformatics, and then learning your first commands. So let's just go through these. So how do I get to my desktop from here?
Okay, so, I mean, would you first check out PWD where you are?
Where am I?
All right, and then you could do, I believe, CD desktop. I think you have to have a space in there.
You sure do. I'm going to be doing that a lot all semester.
Being literal?
Being literal.
Okay.
Absolutely. Okay.
Then you could check it again with PWD, and you're in your desktop.
Okay, I'm in my desktop. Now, on your desktop, you've got two folders. You've got data course Zahn and data course your last name. What is in data course your last name? How do you find out without going into it?
Cat, and then put in data course your last name. Oh, it is a directory. I should know this. We covered it last time. Somebody else help me out.
Does that look familiar?
Oh yeah, LS. That
LS. Okay.
Lists everything that's in it.
Right. Now, look at what I'm doing here. This is actually a bit different than we've done before. Before, we went into that directory by doing CD, right? CD, data course, last name, and then LS. And it shows me I've got something called blah.txt. Okay. I'm going to go back to my desktop by doing CD space ... That means just go back one. So I'm back in my desktop. Now I'm just going to say ls data course Zahn blah.txt. That's a relative file path that we just used. Okay. I told the ls command to list the contents of a directory that I wasn't in, and that's fine. So if I'm in the directory, like here I was in data course Zahn, and I just said ls, it's going to list the contents of where it is. Since I told it list the contents of data course Zahn from my desktop, it went into that, found the files, displayed them here, and didn't actually move. So if I do pwd, I'm still in my desktop. Okay. So that's your first relative file path. Just kind of stash that away in your consciousness for a second. The other file on my, or folder on my desktop is data course. Okay. So I'm going to go into data course, CD data course, space data course. I'm going to look around, and this is what you should see. Do you have that?
Yes.
All right. Everyone else?
Yeah, I have that.
Okay. So here's your next shell command you're going to learn. CP.
Okay, real quick question.
Yes.
So for doing ls and doing the relative file command, I tried doing it like 2 layers up and it didn't work. Do you have to be like 1 layer up? So did I do something wrong?
Matter of fact, let me demonstrate. So here I am in my desktop.
Okay.
I'm going to say ls data course, and then exercises, enter. So it can go as many levels deep as you tell it to, as long as you give it a path that's valid.
So
I did have something called data course in my desktop, and inside of that there was something called exercises, and so that'll work.
So if I was in just my profile, I would have to do ls, desktop, then data course, and then deeper. Okay.
Yeah. Okay, so I'm going to go into data course again, look around. So we've got all this stuff here. We've got readings, assignments, data. How would I see what's available in data right here?
ls space data.
ls space data. We got a whole bunch of stuff. Okay. And if I do pwd, you see I'm still in my main data course folder. Now what I want to do is actually copy all the contents from my data course into yours with your last name. In other words, I want you to have a folder in your data course last name called assignments, okay, and one called data and exercises. So how do we do that? Well, if I open up my little Finder window here, I can just double click on, on data course, highlight everything, copy it, and then go in here and paste it. But sometimes we're going to be doing that for thousands of files or for files based on some condition, and you don't want to spend 6 hours of your life copying and pasting things one at a time. You really don't. So doing it in the command line can be pretty quick. There's a command called cp. What do you think that stands for?
Copy paste?
Just copy.
Okay.
Yep. But what it actually does is copy paste. Yeah. And the way CP works is there's a bunch of different flags we can give to it, but copy source to destination or multiple sources to a directory. So it wants two things basically. Copy, give it any options, and then it wants the source and then where to send it. So if I look around, I see something called assignments. So watch this closely. I'm going to copy assignments to ... data course zon.
That is what I just instinctively tried. It gives me an error. It wants something more.
Yeah. What's that error tell you?
-R not specified.
Okay, so
directory,
I'm going to look up here in my little help file for CP. There's the -R. It means recursive. Copy directories recursively, so everything inside of it. So by default, copy doesn't like to copy a directory because it doesn't know if you want all the files. So I'm going to hit up. I'm going to go way back here, type in a -R.
So that's saying copy, and you're allowed to copy everything in assignments to data course zon.
And data course zon will be found one directory up.
Okay, that's what the dots.
So that ... means there is nothing called data course zon where I am right now. In order to find that, you're going to have to go back one level into the directory or into the desktop, and then you'll find data course zon.
If you needed to go back 2 levels, would you put 4 periods? ... slash
like that.
Okay.
Yeah. And this is going to give me probably an error. No, it'll do it. It just made a new directory. Yeah. Okay.
Do you know of another like code input for help that would work on a Mac? Because
You may try just -H.
No.
Okay, see, on mine it says try CP help. Now try this, man CP. That stands for manual. That might get you there.
Yep.
Now this will let you scroll up and down with your arrow keys, just looking at the manual. And then if you want to quit, you just push the letter Q to get out of this.
So mine came up with a colon, and
When you typed in man CP?
I hit F on accident, and now I can scroll.
Oh, okay.
So
Okay. So I'm going to look around here. I'm still in my plain old data course. Let's copy something else. How about the data? Walk me through that.
Okay, where do you want to copy it to?
Into data course, your last name.
All right, so CP and space everything. Are we copying everything in there?
Yep,
Dash R.
recursive.
All right. I think another space, or does there have to be a dash? All right.
No, space. Yep.
And then we're copying data, so data, and we're copying it to, it would be our last name, but is that, how many levels up is that? It would be
Right now I'm in
data
desktop
course.
data course. So I need to go back one to desktop and
So
then forward into data course, my last name.
So then that would be ... backslash, and then forward would go into, okay, so that's, oh, does that do it?
Yep.
Okay, so that's saying just go back and then forward into that.
Yeah, so let me walk you through this in plain English. Copy recursively this directory called data found here, where you are, and send it back one directory and then forward into data course Zon, which is found in this back one directory, which happens to be our desktop. Enter.
Could you do that again for Mac? What was different on Mac? I can't remember what. Didn't somebody just say like it was a little different on Mac?
To find the help file.
Oh,
man
okay.
For manual.
Uh-huh.
To be perfectly honest, normally I just Google it so that I can have it on a separate screen.
Okay, but it should be the same thing for Mac, that -R and everything.
Yeah. Mm-hmm.
Okay.
Now, when I Google, the way to do it for command line is to type in bash and then the name of the command and then help. And that almost guarantees it's going to be your first hit. Yeah. So there's the help file for copy.
Okay, awesome.
Bash is the name of the command line we're using. Okay. Now I've got a challenge for you. Navigate to your last name data course directory, and then from there, I want you to copy code examples from my data course into your last name. That make sense? Right now we are in regular old data course, I want you to go to data course your last name, and from there, copy the code examples folder into that directory. So that in data course your last name, you'll have assignments, data, and code examples. Let me know when you found the solution.
Just copy it into our folder directly.
Yeah, from the command line.
All right, did it.
Okay.
What were we copying again? Was it code examples?
Code examples.
Okay.
I got it.
Was that Trevor?
That was me. That was
Okay.
that was Trevor.
Are there any undo commands?
No.
No. Okay. Yuppie. I guess it's why you copy and paste it from GitHub repeatedly, huh?
Yeah. The thing about copying is that you're not messing up your original file. So if you just moved it somewhere weird, you can delete it later and just try again.
So you want to push it frequently, well, not really frequently, but as soon as you know it works, in each chunk, yeah.
Yeah. I wouldn't do a git push just yet. All right,
Okay.
who's having trouble?
Help me out here. So
Me.
I got copy CP, put everything in it, -R, and I'm doing code examples. I'm currently in data course hall,
Okay.
which means I would then have to go back up, right, one. Then would I direct it twice? Would I say then go into data course, then data course hall?
No.
Or just then go into data course, and then that's that, enter.
That's that. So let me
Okay.
walk you through this. It seems like some of you might be maybe a bit confused here. I'm going to do cd ... Where does that take me? To my desktop, because that's back one. Okay. I look around. I've got data course here and data course is on. So I'm going to do cd data course is on. Okay. There I am. I I look around. Cool, I've got my assignments there. I've got data and whatever was in there before. Now I want to copy recursively that code examples that was found in data course Zon. To get to data course Zon, or data course rather, since I'm in data course Zon right now, I have to go back one into my desktop before I can go forward into data course. That make sense? So I'm going to go back one into desktop, into data course, code examples. So I am copying recursively this directory, and I'm giving my computer directions on how to find that directory. I'm telling it, hey, you need to go back one and then into data course, and then in code examples is the directory I want to copy. And then I'm going to tell it to copy it here. Now here's a little shortcut.
Did you put a space after the backslash from examples? So it's
Yeah.
examples backslash space dot. Okay.
Uh-huh. What is this dot?
I assume that represents the directory you're in. Or, yeah.
One dot means where I am right now. Two dots means my parent directory, the directory that contains me. So that's why two dots actually means back one, is because it goes into the directory that contains the directory you're in. Okay. If I show you this tree here, this is what your computer's file system looks like. Everyone starts with this backslash. That means your root. That's your entire computer. Okay. In there, you've got all kinds of different folders. In each of those folders, there might be other folders. Okay. So if I was in John here, and I wanted to copy main.c into Mary, how would I go about that? I'd have to say copy hw1 backslash main.c space dot dot, going back up here to user, backslash Mary.
So whatever the final thing is, that's what it's going to paste it into.
Yes.
Okay, everything else before that is directions to copy.
To what you want to copy.
Okay.
So copy is going to work that way, where you give it whatever flags, like the R, saying it's okay to copy a directory, and then you say what you want to copy, and then where you want to copy it. But does this make sense that if I was in John and I wanted to copy main C into Mary, I'd have to say copy hw1 slash main C space dot dot backslash Mary. I'm giving it directions to where all these files are and where I want them to be. And the way your computer reads directions is relative to where you are. So it knows that you're in John, let's say. But it doesn't, it's really dumb. It doesn't know off the bat that Mary is going to be found one space up in the user directory. You have to tell it that. So same thing is happening here. I'm saying I want you to copy code examples to here. But it doesn't know which code examples I want to copy. There could be 5 different folders named that on my computer. So I have to give it solid directions to get there from where I am. And so I have to say, if you want to find code examples, first you have to go back one into desktop and then forward into data course. And there you'll find code examples. Once you've found that, I want you to copy it to here.
All
Okay,
right.
so if I run that and then look around, now I've got assignments, code examples, and data. I do ls space dash l, that lists things in long format. Like, so it puts one on each line, and it gives me some info about them, like their size, when they were last edited, that kind of stuff. ls-l, so list it long. If I do ls-a, it shows me assignments, code examples, data, 2 dots, 1 dot, and dot get. What does A mean in this case?
Application?
Wasn't that list
All.
hidden things?
Oh.
Yeah.
It's the hidden files too. So in your terminal, actually your computer actually stores it this way too. Any file name that starts with a dot or folder name that starts with a dot, it's hidden by default.
Can tabbing still see it? If you try to tab, will it still fill in the hidden file?
Yeah, it still will. It knows it's there. It's just hiding it from you to keep the clutter down, I think. This .get, that's hidden for a reason. They don't want you messing with that. That's all those saved, stored versions of your like Git repository that you've committed in the past. They're all stored in that .get. Okay. So if I do ls-al, what do you think it's going to do?
It's going to both list everything and in long form.
Everything and in long form. So there, it shows me dot, which is kind of dumb because that just means this current directory, but it shows it to you. It also shows you dot dot, which is what?
Parent directory.
Parent directory. So the directory that contains this, it gets a special shortcut. And then there's assignments, code examples, data, and my hidden Git repository. All right. So I want you to have your data course last name set up like this, where you've got assignments, code examples, and data. There's a reason for that. It's because all of your assignments are going to have to be relative file paths. Okay? Otherwise, they're not going to work on anyone else's computer. Let me show you an example of that. Opposed to relative file paths are absolute file paths. And that's where you're giving it the complete directions starting from the base of your computer all the way to the file. So I could say copy root copy root user. How do I get there? Okay. When I do pwd, it shows me the absolute full file path. So I could do copy root home gzon desktop data course readings stats paradigms.jpg, and I could copy that to here. If I look around, there it is. And I can view that file. Okay. It's there. But what if you typed this exact command on your computer?
There'd be no such thing on our computer.
Absolutely not. The odds of you having a username gzon are pretty slim. Okay? It's just not going to work. So in order to make any code that we write portable between computers so I can actually grade it or so somebody else can run it, you have to use relative file paths. Okay? Because that way it's the same no matter wwhere you are. If we all have the same data course last name structure, where we've got an assignments folder and data folder, then when you're doing your assignments, you can actually use relative file paths with like ... data, all that stuff. And it'll work on my computer. You can share your code with other people and it'll work. Questions so far about relative and absolute file paths? It's somewhat intuitive, but it's also such a new thing to think about that I get that it takes a while. This tends to be a pretty big sticking point for students. If we don't cover this really well and you don't really know what's going on, you're gonna suffer. So let me know if you have any qualms.
Okay. Go, Steven.
I was just gonna say, I made it through the same directory, but I am not finding the code examples in mine. It only shows the README and a text file.
So you didn't copy it?
I don't think so.
From data course to data course hacking.
Yeah, I don't think so. I probably got stuck there.
All right. So where are you right now for what PWD gave you?
I'm in my data course, but I can navigate to the other one really quick.
No, you can stay in yours. That's fine.
Okay.
So you're gonna copy recursively ... data course / code examples to here. Right? So we're giving it directions on how to find code examples. It's one directory back, and then in data course, and then code examples is there. And then you're going to copy it to here.
So I think that's where I got stuck. It says cannot stat. So I needed to add in more after that last slash, right?
Nope.
Okay. So I have exactly what's on your line, but it's saying cannot stat. No such file or directory.
Okay, so are you sure that you're in your data course?
Uh-huh. With hacking at the end? Yeah.
Okay, and then it's in your desktop?
I moved it to a folder in my desktop, but I navigated there. Is that going to make it weird?
That's going to screw you up. Put it, yeah, so that,
Okay.
You don't have anything that's back one and then data course?
If I go back one, it'll go to where I have the other data course. Yeah, so it's just one step back.
Okay.
But I can put it on the desktop if that.
No, that's fine.
Okay.
As long as it's one step back and then you've got data course there, This should work. If you're getting a file not found error, It means that things aren't where you say they are.
Okay. I'll rearrange them a bit, put it on the desktop, and see if it works.
Okay.
Okay.
All right, here's my question. So maybe I missed it or misunderstood when you were explaining it. What allows something to be a relative, well, what do we call it, file path, was it?
Nothing allows it. It's just one way of writing a file path. And what makes it relative is that the directions to the file or directory that you're trying to give start from where you are. That's the only difference.
Okay, and direct starts from the root?
From the root, yeah.
Okay.
So the absolute file path is a long convoluted path from the beginning of your computer all the way to the file. The relative is the directions to the file from where you are.
Okay.
So if I'm in John, the directions to main.c is hw1/main.c.
So you could say that hacking's problem was not having the same relative file path as us?
Yes.
Okay.
So we're trying to get all of our stuff lined up in the same places on our computers to make it easier for the class just to work.
Yeah.
Okay.
As a matter of fact, not just easier, it makes it possible for the class to work. Without that, it's not going to be possible. So consider this. You've got, now you should have a folder called assignments in your data course. I'm going to go into that, and I'm going to look around. There's 10 assignments. We're going to be working on assignment 2 this week. So I'm going to say CD assignment 2. I'm going to look around, and there's an HTML. That's what you find online from our website. There's a PDF version of that too, if you prefer, and something called RMD. That's how I made the HTML. So let's look at assignment 2. So it's having you find a bunch of files that begin with M in the directory data, data shell, data, PDB. That's confusing. It only works if you have the same file path, relative file path. So if I'm going to look for that, I'm actually going to do my assignment 2 from this directory. Does that make sense? So any of my commands have to start in assignment 2 directory. And so if I want to find data, I have to say ... what? Data. Data shell. What was it? Then data again, and then PDB. So from assignment 2, I'm telling it how to get to the files that I care about. If you have a different directory structure, your code, your answers for assignment 2 won't work. The way I'll grade these is copy and paste them into my terminal and see if they work.
Oh, okay.
Yeah. If I can't copy and paste it into my terminal and have it work, it's not correct.
All right. I have a follow-up question. This one
Great.
should be pretty quick. So when we are doing the copy and paste, let's say we're copy and pasting assignments. All right. After I type in assignment /, could I then, if I just wanted assignment 2, specify assignment 2 or assignment _2, and then do space period /, and that would just copy and paste assignment 2 into mine? Okay.
Yes, absolutely. Okay. So that was a long way of learning copy, but we learned copy, hopefully. Where's the thing, and then where to put it. All right. Oh no, Control C. Right. So we got copy. Now if you look at assignment 2, for each of the file names that begins with M, that should actually be a lowercase m, sorry. I'll change that. In the directory data, data shell, data, PDB, list the number of lines in each file. Ooh, oh dear. Well, here's all the files we've got. Which ones begin with M? All right. So now we're going to learn the wildcard. That's your star, Shift 8. Wildcards are super, super, super handy. They let you match things with kind of fuzzy logic. Okay. So if I hit up here, so list, go back to, and then you'll find data, data shell, data PDB. If I list all the stuff in there, there it is. if I list M star, what's that going to give me?
That is going to give you, it's going to list everything that starts with M.
It's going to find any file that begins with a lowercase m and then ends with anything. The star means match 0 to infinity of anything. If I do m star dot pdb, what's that going to match?
It's going to take out the M lines text file.
Yep. So it's going to match anything that starts with an M, then has 0 to infinity of anything else, and then ends with .pdb. All right, so the star is super handy already. That's awesome. All right. And we used it with our ls command. How would I get the number of lines in each of those files? We learned this one last class period, but it's been a few days.
Yes. Didn't it start with a G?
Nope.
No. Okay.
I think you might be thinking of grep there.
Yeah.
Isn't it WC?
WC-L is the number of lines. WC by itself gives us the number of words, lines, and characters. So WC-L slash data show data pdb m star dot pdb. All right, that looks long and confusing, but it's not too bad if we break it up. We want to do the word count program showing just the number of lines, and the files we want to count are to be found 2 directories back and then forward into data, then data show, then data, then pdb, and they must begin with an M and end with pdb. So if I run that, check out the output. There it is. It's the number of lines in each one of those files. This is where practice really helps you type it faster, because otherwise you're kind of scrambling around trying to remember stuff. This is the muscle memory for sure. Remembering that WC-L counts words, and then remembering your file paths, how to get there. And the greatest trick of all is that tab button. Tab auto-completes. And so if you hit tab a couple times and it doesn't autocomplete or give you some options, it means you're in the wrong spot. So let me type it in real time for you. Word count, I'm going to list the number of lines. I'm going to go back to capital D tab, data, cool. Lowercase da tab, data shell. Lowercase d, data. P tab. Oh, P tab didn't work. There's a couple options because we had something called planets, txt. So PD tab. There we go. Then m star dot pdb. All right. So you can imagine if you had, I don't know, like 10,000 files like you get back from a sequencing machine, being able to count the number of sequences in each one with a command about that long takes seconds. Okay. If you were to try to open up like a graphical user interface program and load them all and do that, we're talking close to half an hour before they're loaded into memory and it counted the lines and stuff. All right. So that right there is literally the answer for task number 1. So this line of code, I would copy that, paste it into a text file, and upload that to Canvas for answer number 1. That make sense? If it doesn't, if we're still having trouble, let me know. After this week, we're not going to be in the command line very much. Okay, maybe just for some Git stuff. But guess what? File paths work the same way in all computers. And when we're doing our R coding, you're going to have to understand those file paths, or they will kick you in the teeth. So let me know.
Should we have copied over data? Should we have copied over data to our main folder to data course our last name?
Yes. What I want you to have is assignments, code examples, and data. Not stats paradigms necessarily. I don't care if you do, but you can give no need. So I'm going to teach you a very dangerous command. As a matter of fact, I have a whole video on potentially dangerous command line errors. Please watch that, but I'll show you in real time. Do not type this along until you're comfortable. RM. This is remove. Removing a file in the command line, like we said before, there are no do-overs. There's no undo error. This will let you remove very important things. It does it instantaneously, and it's non-recoverable. Maybe the FBI would be able to like get the data off your computer if you're lucky. Okay. Remove, you can give it a path to a file. You can give it a directory if you tell it to work recursively. That's very dangerous. So if I remove stats paradigms, it's gone. That's it. It's gone forever. If you do that to an important paper, it's gone forever.
What about something like remove desktop?
That will work.
Oh no.
Yeah. I tell you this because I think it's better that you know the devil than not know it's there. You don't want to accidentally type remove desktop. It's going to tell me no if I hit this because it's going to say that's a directory. You need to put an R before it. Now, if I hit enter right now, this entire video chat will die instantly. My computer will shut down.
Don't do it.
I'm hitting backspace very carefully. Okay, and then delete. Okay. Very dangerous. The people who wrote this bash command line, they figured it was better to give people absolute power and just trust them to not be dumb. It's kind of like with great power comes great responsibility. They did not want to prevent people from doing really clever things with their code. Like maybe you do need to remove something instantaneously as part of your workflow automatically. So they let you do it, but please be aware, unless you're really certain about things and you're really comfortable with the command line, just avoid typing RM. If you want to remove something, I would go in with this and say delete, move to trash, because then it's at least in your trash. Move to trash. See, look, I can undo that. Oh, how nice. That's excellent. Remove blah.txt. It's gone. Okay. If you want to get really crazy and you're like involved in insider trading or something and you need to hide evidence from the FBI, there's a command called shred. And what this does is randomly overwrites that file with ones and zeros about 10 million times and then deletes it forever. And so it's absolutely non-recoverable. Like even with top forensic stuff. All right. So be careful of that, but there you have it. Watch my little safety video. All right, so we refreshed on word count. We learned copy. We're pretty good on cat. That just spits the contents of a file up. All right. Now for assignment 2.
What about saving our progress so far that we've made for copying and pasting, would the same git add readme?
Yeah. Git add dot means add everything in this folder. It's going to take a second because there's a lot of new stuff in there. Okay. Then git commit some message, enter. Oop. Cool. And then git push.
Okay, so git add dot, super useful.
Yeah, nice shortcut. All right. Now, part 2 of that assignment is I want you to make a new file called m_lines.txt that contains assignments, assignment 2, that contains this output. And the way I said it was redirect the output from the previous task to a new file. So now we got to learn about redirect. That's this and that. So greater than and two greater than symbols. So let me show you how this works. Here's this command. We got it working. We see the output on our screen. But what if you don't want to save the output on a screen? What if you want to store that somewhere? Right, somewhere safe that you will refer to later. So I can hit up. And I'm going to redirect this output from my screen to a file. Just with that little arrow, basically. Now, if you do one arrow, this will overwrite the file. Okay? It will create that file, empty it, and then put the contents from this previous command into that file. So I'm going to hit enter here. Nothing happened. Well, if I look around, there's mlines.txt. How do I look inside that file and see what's there?
Cat. You'd run a cat.
mlines.txt. There it is. So I've got a little text file, and it's got the output from my previous command. Now, if I say echo blah, blah, blah in quotes and send it to mlines.txt, what's going to happen?
It's going to get rid of the command you just did.
It will. Cat mlines.txt. There's the contents. So a single greater than overwrites, two greater thans appends. So let's see. Instead of that one, I'm going to put, well, I'll do it one there. Okay. Then I'm going to echo all that stuff and two greater thans. Now what am I going to see if I cat this file?
Same line twice, right?
Nope. I'm going to see the original contents of that file. And then on the next line, the new thing that I sent there. If I say echo new line, send it with 2 to mlines.txt, and then cat mlines.txt. We've got the original contents, that thing I echoed, and then my new line. So it just adds things to the bottom.
Okay. Let's say that you're doing some data analysis, right?
Mm-hmm.
You get these lines here, and you decide, okay, 224 in total. I want to save that. All right. Is there a way to say, hey, save what's above this to somewhere? So you have your command line right now. Do you understand what I'm saying?
Do you want to save
the previous
just this
result.
line somewhere?
No, everything that's like above that between your JSON, yeah, all that stuff. So the output from my previous command to somewhere.
Yeah.
Is that a thing?
That's a thing.
Okay.
It gets a little bit hairy because we have to use pipes. I'm glad you brought it up because unless anyone has questions about redirect, pipes was the next topic.
So I actually did that, and I only did it once, but it put in the line count twice into my file. I only did it once, though.
Did you have 2 of these or 1?
I had 2 of those.
Okay.
Oh, so you needed it once?
Well, that means that you already had something called mLine_set_text. I may have accidentally left that in the assignment.
Oh, okay.
And so then you just added to it. Yeah.
So here's a question. Can you use a pipe to take something from a cat command, from a text, to execute another command?
Yeah. However, you have to learn how to actually do some shell coding, scripting. So that's part 2 of this course. I'm not going to get into that. That's more like hardcore bioinformatics.
All right.
Yeah. But yeah, it gets really handy. You can actually use grep to find certain lines, have it split them up and pick out pieces of them and use those as input for other programs. And it's pretty straightforward, but beyond the scope of this class. I'll be teaching it in the spring. Yep. As a trial run for our new bioinformatics program. All right, so pipe. Let's say you just want this stuff and not this line to be sent to a file. Right, that's what you were getting at, right, Dalton? Okay. Well, we know a few commands that'll get us there, as a matter of fact. So let's try this. Instead of sending our word count to mlines, let's pipe it to tail. What's going on?
It's going to give us the last 10 lines of everything in there.
The last 10 lines of the output from this. Now, if I do that and say tail 1,
is that just the first line of the tail?
It's the last line of the file, or of the output from this. So this command right here gives us all of that. If I send the output with my pipe to tail 1, it's going to take this and just give me the last line.
Can you select multiple individual ones, like if you just wanted line 2 and line 5?
It's kind of tricky. Let me show you how I would do line 2. I would say head 2, and then pipe again, tail 1.
What determines if you choose head or tail? Like if there was something right in the middle, what would you choose?
Well, like here, I just want this line 2, so that's right in the middle. I'm going to tell it to give me the first 2 lines, so it's going to give me those.
Okay.
And then of those 2 lines, I'm going to tell it to give me the last line, which is just that. So we can use head and tail together. If I hit enter, sure enough, there it is. Just the second line.
So is head counting down from the top and tail counting up from the bottom?
Yep.
Okay.
So how would I get this to give me the third and fourth lines of that
head
output?
3, tail 1.
So that's the third line.
What was the other one you said?
I want lines 3 and 4.
So for 4, would you do head 4, tail 1?
Yep, I could divide it up that way and do it in 2 commands, or I could say head 4, tail 2. So it's going to give me those first 4 and then the last 2 of those.
Okay.
Would you, let's say you wanted to do 3 and 4 along with the very first one, so it skips something in between. Would you need another pipe, or what would?
You'd have to break that up into 2 commands.
Okay.
Mm-hmm. So doing it this way with head and tail, you have to have continuous lines on this. If you want to put it in a single command, you can tell it to give you the third line, the last line, the first line, or the third and fourth, or the third, fourth, and fifth, but you can't say lines 1, 3, and 7.
Okay.
Yeah. Now you can do that in R pretty easily, and we'll see how to do that. What I want you to learn from this little example here is how we can take the output from one program, wc-l, on this file, or these files, take that output, pipe it into something, and then pipe that output into something else. We can chain together as many commands as we want. Okay, so we're taking, these are all really simple programs that don't do very much. WC just spits out the number of lines, characters, or words. It's an entire program, right? But that's all it does. It just does it really well and really fast. The authors who wrote the command line that we're using, this bash scripting, they made a bunch of tiny programs that do one thing really well and left it up to the users to chain them together to do creative things. So kind of creativity is the limit here. All right, so this is one way of chaining together 3 programs, WC, head, and tail, to get that output. Now, if I wanted to save that, I could then just send it to a new file. So if I cat new file now, there it is. If I look around, there's new file. So between pipes and redirects, you can do a lot of really neat stuff and save your results in a new file. All right, this is a lot of cognitive information. I'm sure I have not explained this well enough.
For a reference, could I just click Google something like GitHub shell commands as a refresher for, like, you know, PWD, all that kind of stuff if I forget something? Is that what I should Google for?
I've got that. I've got 3 little videos for that right here.
Okay.
First commands covers like CD, PWD, LS, copy, yeah, all that stuff. And then basic Unix commands right here kind of walks you through some handy stuff. So who am I? Show your username, right? LS, list files and directories. Okay. Cat, more, less, head, tail, grep. So it's just a handy little reminder sheet. But if you're wanting more depth about what they're doing, this tutorial was actually probably better. Okay. And then if you want to learn more about the flags, like we put an R after copy so that we can copy a directory, there's a video right here about what those flags are all about. Okay. And then please watch this one about how not to remove your desktop. I do not want to be accidentally responsible for the destruction of your computer. Okay. So the answer for part 2 here, redirect the output to something called mlines.txt in your assignment 2 directory. Is that. So when you hear me say redirect, that's what I'm referring to. We're sending the output to a file. Because the default for all these shell programs is to spit out the output onto your screen. That's handy for you, the human, because you get to see it, what's happening, but it's not saved anywhere. And what are the odds that you're going to remember that there were 9 lines in methane.pdb? Right, 0. Okay, so we save it to a file. Okay, so redirecting kind of lets us stash our results in a file.
So why wouldn't we want to do the 2 greater than signs? Is it just because we don't have anything in it already?
Yeah, if you don't have anything in it already. If you want to add lines to the bottom, then you would do 2.
Okay.
Yep. And I should point out that you can call this anything you want. Even though I don't have that file, it will make it for me if I redirect to that file. So you don't have to like make a file first. It'll do it automatically. I can cat that, and there's our results. Now I'm going to remove it, and it's gone forever. All right, let's try number 3 here. For the files animals.txt in data shell data, get an alphabetical list of the unique animal types and redirect this list to a new file called uniqueanimals.txt in your assignment 2. Oh boy. So here I am. I'm in assignment 2 of data course my last name. And the file I'm looking for is where? Data shell, data. Okay. So how do I find that? Well, if I'm in assignment 2, how many do I have to go back?
1?
1 gets me into assignments.
Oh, then 2.
Yeah. 2 gets me into data courses on. So if I do ls ... now I can go into data shell, data, and there's animals.txt. How do I look at the contents of that file from where I am?
ls space animals txt.
Nope. If I do ls
yeah
animals, there's nothing there.
Okay.
Would
So
you do cat
data,
then direct it to where it needs to
data
go?
shell.
Oh,
Data.
you're still in the other one.
Uh-huh.
Okay.
So I'm saying, hey, little person in my computer, I want you to puke up all the contents of this file right here. And the directions to that file are you got to go back to and then forward into data shell data, and there you'll find it. All right, there's the contents. And what was our prompt? What are we supposed to be doing here?
Alphabetize.
Alphabetize the unique animals found in there.
There's duplicates of rabbit.
Uh-huh.
And deer.
And if we try to alphabetize it right now, it's going to alphabetize based on the numbers, the dates, because that's what comes first in the line. All right, you ready for another command? I hope you're writing these down somewhere, like keeping track. Cut. All right. So let me hit up. So we're gonna cat this out again, okay? And instead of catting it out, I'm gonna pipe from cat to cut. You know why? It's because I want to split this file, the contents of this file, up into 2 columns. I've got a date, then a comma, and then the name of the animal. All I want for this question is the names of the animals. Then I can alphabetize them, remove duplicates. All right, so cut lets you take, it works on each line of your text. It looks for a character, and it splits that line everywhere it sees that character. So I have to tell it what my delimiter is. I'm going to say, I want you to cut every time you find a comma. And then I have to tell it what fields, what columns to keep.
Why is the D in there? The dash
Delimiter.
Okay.
All right, so this will get you playing with flags, right? You can imagine how much practice it's going to take to get the hang of this. I'm thinking like probably 3 hours before you have this down and are comfortable using the file paths and piping things, all right? So don't forget to do your practice. I'm catting the contents of this file, and instead of letting it come to my screen, I'm piping that to a new program called cut. And then I'm telling cut, I want you to use comma as a delimiter, and then to take field number 1. So what do you think the output of this is going to be?
Just deer.
It's the dates.
Just the dates.
Because you set it at the comma.
It split this up on the comma, and then it took just that first field, the dates.
Oh, the first part of it. So everything that was before it. So if you wanted
Before
everything
the comma.
after, you would
Yeah.
put 2.
If I wanted just the animals, I do field 2.
All right. And then I take it there's another command to get this in alphabetical order.
Sure is. I just hit up again. This is actually how I work in the command line, is I look at the output for my stuff one thing at a time. When I get it the way I want it, I hit the up key, I pipe it to the next part. Sort. Based on unique stuff.
But does unique doesn't necessarily mean alphabetical.
Well, let me take the U off. So here's the sorted list of animals. I looked at the contents of that file, sent it to cut, split it on comma, took the second field, which is the animals, and then I sorted that. I've got bear, deer, deer, fox, rabbit, 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 raccoon.
Okay.
What I could do is hit up again, pipe it to unique. Now what unique does is any lines that have 2 or more that match each other, it takes off the bottom 2, or whatever. So it leaves 1 behind. The sort -u is just kind of a little shortcut for the same thing.
And sort is what alphabetizes it?
Sort alphabetizes it.
Okay.
Yeah. So we're using 1, 2, 3, 4 programs chained together with pipes, and there's our alphabetized list of all the unique animals. Okay, why, oh why, is Dr. Zahn making you look at unique animal names?
For practice.
Well, what use could this possibly have?
To store your data and separate it.
You could look for unique DNA sequences. You wouldn't want repeats.
Yep. Exactly. Working with DNA data is just text.
And so if you're looking for, what are they called, a snurp? Like one single base pair change out of a bunch of stuff, you could use that and see all the unique single base pair changes.
Yeah, and it works almost instantaneously. This will work on a 2 gigabyte size file in a matter of seconds because of the way it's written. It's really fast. It works one line at a time, and you don't have to have a big computer. You don't have to read it all into memory. And so a lot of bioinformatics is just chaining together little stuff like this. Okay. Now we're practicing on whatever this is, bear, deer, fox, rabbit, because it's nice and small, it's easy, okay? And the original file was just split by a comma, which is nice and handy, okay? Now, I did say to redirect this list to a new file called uniqueanimals.txt. So how do I do that?
Okay. Essentially, you would take where you're at, and then
I hit the up key. Oop.
Wouldn't you do an over arrow? And is there already a file called that? No. So can you just type in a unique, whatever you wanted, the unique animals.txt, and it would create one?
Yep.
Okay, so then enter, and that should work.
It appears to have worked. Let's look at the contents. It worked. All right, so that's question number 3. How much time do we have?
We're past.
Are we?
Yeah, 10 minutes.
Oh. I'm sorry. You can leave.
I mean,
I get really excited.
if you want to keep going over the rest of the assignment, I'll stay and.
That's what I'm going to do, okay? I'll give us another 15 minutes. Let's see what we got through. Head, tail, cat, sort, unique. Move, remove. Okay. The only other thing I really wanted to get to was find. But I'll wait for next class period on that. Because I want to make sure everyone's here. I don't want it to be like extracurricular, okay? That's the only other thing you'll need to be able to complete this assignment is the find command. But I'm going to go through the next one here. We've got in the directory data something called biologplateData.csv. Write a command that gives a list of the unique carbon substrates and save it as unique C substrates.txt. Well, that should be super easy. We just did it with the animals. So, walk me through it. I think you're muted, Tyler. Were you talking?
You're right, I'm sorry. Yeah, are you going to copy the data file and then pipe it to where you want it to go?
I'm not going to copy it.
Okay.
Probably going to cat it.
I can cat the contents. Where is it?
In the directory that you get if you press up, I think, right?
It's back to in data. And it's called biolog plate data. There's the contents. So I definitely want to look at it. I want to break my shell command. I want to grow it and look at each step to make sure I know what I'm doing. So here's the contents.
And then what was the
goal
big file again?
I want a list of all these unique carbon substrates.
Okay. Then you would take that, so you press, I think, up, right, to copy it all, and then you would cut it.
How?
But you would pipe, right?
Pipe.
And then you would cut, and you would specify in quotes the comma. Well, actually, there's 3 commas.
Yeah.
So would you then say 3, or the field? It would be 3.
Or head with the lead?
Head gives us lines. I want columns.
Okay.
There was something else you did that wasn't the field. What was the thing before that?
We have to tell it the delimiter.
Yeah.
Yeah.
Okay.
And then we have to tell it the field that we want. All right, so this is 1, 2, 3, 4, 5.
Okay, so that would be 5, not 3 then.
So we want that to be 5.
And then I was gonna say then you have to specify that you wanted the unique ones, right?
This won't work though. What? That won't work. Dang, I cannot type. Unique is kind of tricksy. It will only remove duplicates of lines that are next to each other. So if I've got D-malic acid down here, and up here, D-malic acid.
You got to sort it first.
Yeah.
That way they're all together.
That way they're next to each other. Sort unique, boom. So there's my list of unique carbon substrates. And water.
What did we need to do with it? What was the instructions?
Oh, just redirect it to a file named unique C substrates.
Did the same thing as before, where you up arrow to copy all the stuff from above, and then right arrow, or whatever you want to call it, greater than sign, to whatever the assignment specifies.
Yep. And if you're Googling, they're not going to call it greater than or right arrow. They're going to call it single redirect or double redirect.
Okay.
So just so you know, half the battle for learning how to code is knowing the names of things to Google. Just there you go. So we're going to give it a single redirect to unique carbon substrates.txt. Where is that file going to be located? This is important.
That is going to be somewhere in data. Where are we? So we went back twice.
I am in data course on assignments, assignment 2. You can see it at the top here.
Would that send it to assignments 2, since that's where we're in?
Since I didn't tell it to go anywhere else, it's going to put it where I am. Now I could tell it to go all the way back, wherever, and it would stick it there. So that should be my desktop. So let me look at my desktop here. And sure enough, there's unique C substrates.txt on my desktop. You see how I redirected it to somewhere else? I'm looking at a file that's somewhere else. I'm redirecting it to somewhere else entirely. Okay. I double click on that, there it is. Okay, I'm going to delete that. Okay, now this one's kind of tricky. Write a command that finds the longest .txt file by number of lines in the directory data, data shell, data. All right, I'm not going to work through this for you. I want to hear what you think about it. So remember, I've got to stay in assignment 2, so all my stuff needs to be relative to there. So first off, I'm going to list just to see what's there. Data, data shell, data. All right, there's my files. I've got a few txt. All right, so
would you do the word count of all listings? Would that work? And then that would be able to see, or word count and then the lines of everything.
No. That's a directory. You can't do a word count on a directory. I got to tell it to do something to all those files. What do I do for that?
Asterisk.txt.
Yeah. All right, which one is the longest?
The data shell sunspot.
First one.
Right? Quite a bit longer than the others.
And then do we need anything more than that to specify that's that one? So we would do tail and then 1.
Well, is that really safe? Because this one was listed last just because it was last alphabetically. So if I made a new file called zempty.txt and then ran that previous command again, now we got a file with 0 lines, and so if we did tail, that would not be the longest file.
Would you, is there a way to specify then?
Oh, you could sort them by the line count and then take the first one.
All right, so let's try this. Let's just try sort. Oh.
It needs a numerical version, whatever that is.
Sort-n tells it to sort numerically. So now they're in actual order of the file, the number of lines.
Now the tail should work, right? Because it's always going to be at the end with this sorting numerically.
So tail what?
1 or -1.
Oh, so close.
Oh, 2-2. Right? Because that's going to go up 2.
Yeah, but I just wanted this line. I don't care about the total.
Head 1 dash, head 1, tail 2, right?
Well, tail 2, then head.
Oh, okay. Oh, yeah, because we're starting from the bottom.
And look at that. So now, no matter how many txt files you have in that folder, and no matter how many lines they have or what names those files are, this command will every time give you the longest text file in that folder. All right, so this is a safe way of typing it. So now if we add new files to that folder, and we again want to know which one has the most lines, this same little line of code will give the correct answer no matter what. So yeah, we're just using word count, sort, n for numeric, tail, and head, and there's our answer. All right, I think I'll stop it there and we'll pick up with find next time. All right, so go through your resources. I've got practice problems for you, okay? Don't worry about this find exercise yet. We'll cover that next class period. But definitely do practice your wildcards and practice your head, tail, ls, sort, unique, and word count.
Is the assignment due on Thursday?
Friday.
Friday. Okay.
Yeah. All right. So please, please, please get the feel for these by trying it on other files. If you ruin something, who cares? Download a fresh copy, copy it in there. It's okay. As long as you're staying in your directory, you're not going to hurt anything in your computer. All right. So try it on cat. You know, so maybe go and check out elements. Here's some information about elements. I'm going to copy that and say, oh, what's inside? I'm going to cat it. That's interesting. This is a different file format. Maybe you want to try splitting this up based on this character, right? See if you can get the melting point by itself, or find the file with the highest boiling point. It's a tricky problem, but it's actually not conceptually different than anything we've done. Okay, so come up with little challenges for yourself and see if you can do them on different files in here. There's all kinds of files in this data folder just for that, for experimenting with. Okay. I will see you all on Wednesday.
All right, thank you.
Practice or die.
Doctor's on, are you still in?
No, he's gone.